In this video, we'll write the net ionic equation for NaI plus AgNO3, sodium iodide plus silver nitrate. The first thing we'll do is balance the molecular equation. In this case, it's already balanced, so we don't really need to do anything there. Next, we'll write the state for each of the substances. The NaI here and the AgNO3, we're going to assume that they're dissolved in water, and we're going to write aqueous for dissolved in water. We could also check that on a solubility table if we wanted. Sodium nitrate. Nitrates are usually soluble, so we're going to put an aqueous that's dissolved. And then silver iodide. If we look that up on a solubility table, we'll see that it's insoluble. It doesn't dissolve in water. And because of that, it's going to be a solid. It'll be a precipitate in this reaction, fall to the bottom of the test tube. So we write S because it's a solid. So we have the states. Once we have the states, we can split the soluble compounds apart into their ions, and that's going to be the complete ionic equation. So if we look at the periodic table, sodium group 1, that is a 1 plus charge. Iodine, group 17, minus 1. Silver's a transition metal, but it's always 1 plus. And then the nitrate ion, you could look that up on a table of common polyatomic ions or have it memorized. This whole thing here, this nitrate ion, NO3, that has a 1 minus charge. So we had our plus, our minus, our plus, and our minus. So we have the charges on the ions. Now we can split them up. Let's do that. We have Na plus I minus, that's the iodide ion, plus Ag plus, and then we had our nitrate ion, NO3 minus. Let's shrink this down a little bit. This will give us Na plus NO3 minus, and we said we would only split these soluble compounds, these aqueous compounds, apart. This is a solid, so we're not going to split that apart. It stays together. It's the bottom of the test tube. So plus AgI, and that's going to be a solid. We'll just write S there so we remember. Let's shrink this down. So now we have the complete ionic equation, and we can cross out what are called spectator ions. These ions appear on both sides of the equation. Note that I didn't write aqueous in here. We'll do that at the end. But for these spectator ions, we can cross them out because they don't change. You start with a sodium ion and you end with one. So we're not interested in the things that stay the same. We want to know what changed. So I have sodium here, sodium here. I'm going to cross it out. I have a nitrate here and a nitrate here. I can cross it out. And because of that, I'm left with my net ionic equation. And I can write that out. That'll look like this. And this is the net ionic equation for sodium iodide plus silver nitrate. Note that I wrote the Ag plus first. You'll often see it written that way. Either way is fine. That's it. This is Dr. B with the net ionic equation for NaI plus AgNO3. Thanks for watching.